Sir, is it okay, sir?
Sir, okay, sir.
Shall I share screen?
Yeah, sir, I can share, sir.
ఇక్కడ సార్ ఇది ఇదేనా
షేర్ స్క్రీన్ అని ఒకటి ఉంటుంది చూడండి సార్.
షేర్
Now it is okay, sir.
Just a minute, sir. I think other screens I will minimize.
Okay.
Is it visible, sir?
Yeah, visible, sir.
Just one video is there, sir. Just
Okay, sir.
In continuation of my explanation about the working principle of proton exchange membrane fuel cell.
Is it coming, sir?
Yeah, coming, sir.
Okay. So
Your Zoom participants list.
ನಾವು ಸರ್ಟಿಫಿಕೇಟ್ పంపిస్తలేరు పంపిస్తారు సార్ ఇప్పుడు సర్టిఫికేట్ పంపించకుండా కాదు ఆల్రెడీ లెటర్ కోఆర్డినేటర్ ఇస్తారు కృషి కాలేజ్కి దానికి డబ్బులు ఇచ్చిన కోఆర్డినేటర్ డబ్బు వాళ్ళ ఇష్టం కోఆర్డినేటర్ దగ్గర తీసుకోవాలని అనుకుంటారు వాళ్ళకి సర్టిఫికేట్ కొట్టేదమ్మా సంవత్సరానికి ఆ ప్రాజెక్ట్ చేయిస్తాను
ఎవరికి వాళ్ళకా
ఇస్తే వస్తే ఆదేశిస్తాను
నమస్కారం కోవిడ్-19 అన్లాక్
సార్ అన్మ్యూట్ చేసుకోండి సార్, మీరు మ్యూట్ అయిపోయినారు. సరే సార్, అదే 22 మెంబర్స్ వచ్చినారు. స్టార్ట్ చేద్దాం. స్టార్ట్ చేద్దాం సార్. Good afternoon to everyone. So today we have Dr. G. Nagasrinivasulu sir. He is going to give a topic on fuel cell technology, fundamentals and thermodynamic analysis. So first of all, I would like to thank G. Nagasrinivasulu sir for accepting our invitation to give an expert talk on a 2-week faculty development program and renewable energy intervention in industry, domestic and commercial applications. So before handovering this session to the Srinivasulu sir, so I would like to introduce the Naga Srinivasulu sir is a associate professor in the Department of Mechanical Engineering, National Institute of Technology, Warangal. So sir received his MTech degree in the specialization IC engines and gas turbines from the National Institute of Warangal, and a PhD in the area of fuel cell from Andhra University, Vizag. So sir research interests are in the area of PEM fuel cells, IC engines and heat transfer. So sir handling 3 externally funded ongoing projects worth of 1 crore, 1 SERB EMR and 2 SPARC projects. Dr. Srinivasulu sir is handling the courses like turbo machines, IC engines, power plant engineering, automobile engineering, engineering graphics, automotive body structures and heat and mass transfer. So sir has published 30 papers in refereed journals and refereed conference proceedings. As a supervisor, 2 PhD guided and 6 scholars are working. So sir is one of the co-developers in design of pedagogical course, internal combustion engines and automobile engineering. So sir is one of the members in the working group of Center of Excellency on Sustainable Energy Studies for 5 crores. So first of all, congratulations sir, having the 1 crore worth of project. So now I request Naga Srinivasulu sir so to hand over the session, sir.
Thank you, sir. Thank you for your nice introduction. First, I thank the management of RGM College and head of the department, principal, for giving me the opportunity to present my research contributions in the area of fuel cell. Good afternoon, all of you. My topic is fuel cell technology, fundamentals and thermodynamic analysis. These are the lecture contents I am going to cover in today's session. Introduction, principle of operation of fuel cell applications, theoretical electrical work, thermodynamic analysis, flow field plates, and direct methanol fuel cell. Is it visible, all of you? Participants, can you, one of you please respond? Is my screen or slide visible to you?
Participants, please unmute and say.
Okay,
Yes,
sir.
one of
Okay.
you. Okay. Fuel cell is an electrochemical device which converts chemical energy of fuel and oxidant directly into electrical energy. In case of conventional system like IC engine, you see, chemical energy of fuel means diesel or petrol can first burn in the combustion chamber, that is thermal energy released. That energy is utilized in expanding the piston, then we can get the mechanical energy. If you connect the generator to the engine, diesel engine, then you can get the electrical energy. But in case of fuel cells, the chemical energy of fuel is directly converted into electrical energy without any combustion and without the help of any mechanical linkages like piston cylinder arrangement. So that is why this system, attracted the scientists to explore this, for the practical usage. Means this system directly the system, bypassing the combustion and as well as mechanical arrangements here. Introduction. The ever increasing energy demand, non-polluting energy generation, and other environmental issues have encouraged many researchers to look for new efficient energy conversion technology. The widespread exploitation of fossil fuels and the advances in batteries relegated the fuel cell technology to a scientific curiosity. What exactly the point means? The widespread exploitation of fossil fuels and advances in the battery technology relegated the fuel cell technology to scientific curiosity. So actually, the fuel cell was invented in the year 1839, but people has not focused much. But recent days, due to these reasons, exploitation of fossil fuels and advances in the battery technology, again, people have shown much interest in the fuel cell technology. The scientist William Robert Grew discovered the reverse electrolysis process of water. Means water, we all know the chemical formula H2O. Chemically, we can call it as H2O. Means hydrogen and oxygen combined. You want to split the water into hydrogen and oxygen, we need electrical energy. Means if you supply electrical energy into the water, so water is splitting into hydrogen and oxygen. So whatever the energy which required to split the water, if you combine hydrogen and oxygen, then proportionate amount of energy it is releasing. Based on that concept, the author William Robert Grew discovered the reverse electrolysis process. In this system, no moving parts unlike IC engine. Exhaust is only pure water, means here H2, when hydrogen gas and oxygen gas, when they combine, before they combine into H2O, it releases electrical energy. That is why the exhaust from this system is pure water, which does not harm the planet. And also, no moving parts in the system means minimum maintenance. Fuel cell produces electricity as long as fuel is supplied. Means like IC engine, as long as you supply fuel to the engine continues to run and develop the power. Similar way, fuel cell also, as long as you supply hydrogen and oxygen gas, continues to generate electrical energy. The means people, there is a confusion in the word fuel cell and battery. Battery means it is a not continuous process. It is, you can call it as a discontinuity. Means first you have to charge the battery. Battery stores the energy. Then when you take power from the battery, then it continues to discharge. So that is somewhat intermittent process. But fuel cell, it is not like that. As long as you supply fuel, it continues to develop the energy, that is generates the electrical energy. So the fuel cell produces electricity as long as fuel is supplied, which is the basic difference between the battery and fuel cell. So why you are going for this thing, the system, power consumption of personal portable electronic devices like internet routers, cell phones, laptops has been increased day by day, and it is expected more in future. The conventional batteries are insufficient to handle the portable electronic device. Thus, looking for alternate energy source for mobile devices, the proton exchange membrane and a direct methanol fuel cell are found to be the best suitable choice. So fuel cells are different types. They are categorized based on the electrolyte is used in that. We have direct methanol fuel cell, alkaline fuel cell, molten carbonate fuel cell, solid oxide fuel cell, phosphoric acid fuel cell, and proton exchange membrane fuel cell. Now, though we have these different types of fuel cells, depending on the application and capacity, they they are given in this table. It is listed here. Let us say typical. This is typical application: portable electronic devices. Let us say its capacity is 1 watt to 100 watts. For this power range, so direct methanol fuel cell will give better solution. Means it is the suitable uh, type of fuel cell for this application when the application is in the range of 1 watt to 100 watts. And if the application is in the range of 1 watt to 10 kilowatts, proton exchange membrane fuel cell is best suitable system. So I am working on these two cells. So we have the facility in our institute. The scholars, almost four scholars already submitted. Two got their PhD. Then two more submitted. Then six more students are working on direct methanol fuel cell as well as proton exchange membrane fuel cell. In our institute, we have this technology, and other faculty member in our department is working on alkaline fuel cells. Similarly, in the industries, for high power capacity, that is 1 watt to 10 megawatts, this is best suitable solid oxide fuel cell. Then we have other types, phosphoric acid fuel cell and molten carbonate fuel cells. But for low power application, direct methanol fuel cell is best suitable, particularly for the internet routers, laptops, and cell phones. I have one project, SERB project on extramural research, EMR project. This year I completed, and we have developed fuel cells, direct methanol fuel cells. I'll explain in coming slides. Now we'll discuss proton exchange membrane fuel cell first. What is the working principle? How it is operate? Then what are the applications here? Proton exchange membrane fuel cell has an ion conducting polymer membrane as an electrolyte. Means in case of batteries, the H2SO4 is the electrolyte used. But in case of fuel cells, the proton conducting membrane, polymer membrane, means it is a plastic paper, just like plastic paper, but its features means properties are different. Ion conducting polymer membrane used as a electrolyte means here what I mean to say here is in batteries H2SO4 is in liquid form. Here in the fuel cells, the membrane is in solid form. The proton exchange membrane fuel cell system is able to generate high power density and permits faster startup, can operate at low temperatures, means even at ambient conditions also it can work. Now when you look into the illustration of proton exchange membrane fuel cell, mainly it is consisting of three components. One is anode electrode, then membrane, then cathode electrode. And this membrane, it is a solid membrane like plastic paper. On both sides of this membrane, catalyst material is coated. Means like painting on this side, on this surface, the catalyst material mainly made up of platinum and carbon. That paste is coated on this surface. Similarly, other side surface also. Now, this anode electrode means it is a diffusion material as well as current collector. This is this plate. Okay, uh, actually these three plates are sandwiched. Here it is in exploded view, dismantled manner. When this plate is in contact with this, and when you supply hydrogen gas on this side, when you supply hydrogen gas is being diffused throughout this space. And once it comes out from this side, once it comes out to this side, and this hydrogen gas contacting this electrode cell, means catalyst surface, where platinum and carbon reacts with the hydrogen gas, and their reaction is that reaction, it is hydrogen is splitting into protons and electrons. And this membrane having property that it conducts the protons through which but offers resistance to the electrons. So here electrons are available, means H2 is splitting into 2 H plus and 2 electrons. 2 H plus ions will conduct through this membrane and 2 electrons are available here. Now when you come to the other side of the membrane, and this side also the catalyst means the electrode, mainly diffusion material and current collector. When you supply the oxygen gas here, what happens, oxygen reach this catalyst area where it finds H plus ions and it starts reacting with H plus ions. To complete the reaction, it needs electrons. So this side electrons are available. This side electrons are required. Now, when you connect this electrode and this electrode, anode electrode and cathode electrode through a current conductor, that is electric wire, copper wire with some load. Now you see the electrons are conducting through this and reaching this place, completes the reaction. So here 2H plus half O2 will give H2. So here reaction is completing. Now you see when you assemble these parts and when you supply hydrogen gas this side, oxygen gas this side, what happens, as long as electric field is, as long as you connect this wire through some load, electrons continues to flow from this side to this side, because here it is generating, here it is consuming. So electric field generates. So this is the principle of operation of fuel cell. Just a minute. See, the system is very simple and very silent in operation because no moving parts and no combustion here. So heat generation is very, very less here. Now that is why the system has so many advantages. Now people are looking for the system to commercialize this. Now, with this explanation, I have prepared one. No, those you have understood to some extent. Some more points may be clarified by going through my next slide, that is video. So whatever the fuel cell available in my lab, with the help of that, I prepared one video. Please go through that.
In continuation of my explanation about the working principle of proton exchange membrane fuel cell, here I am going to explain the practically used fuel cell. This is called membrane electrode assembly. In this, the polymer paper, is called membrane. Polymer paper is called membrane. Mainly it is made up of Neophene material. And this membrane, both sides of this membrane, the catalyst material is coated. Next to this catalyst layer, gas diffusion layer is placed. Similarly, this side also catalyst material and gas diffusion layer. The complete thing is called membrane electrode assembly. Okay, this is called membrane electrode assembly. Okay, now come to the operation of this fuel cell. Okay, on one side of this MEA is popularly called membrane electrode assembly. When you supply the hydrogen gas, this gas is diffused through this diffusion material. This diffusion material is mainly made up of carbon cloth, just it is a cloth. And catalyst material is made up of platinum carbon mixture. Okay, when you supply the hydrogen gas, this gas is diffused through this gas diffusion layer and reaches the catalyst material. It is splitting into protons and electrons. Then protons are conducting through this membrane, and protons means ions. H plus ions are coming this side. And this membrane is offering resistance to the electrons. Electrons are available here. Now, other side of this fuel cell, you see, this side, H plus ions reached here. When you supply hydrogen gas, when you supply the oxygen gas, oxygen is reacting with H plus ions, and to complete that reaction, it needs electrons. So this side electrons are available, this side electrons are required. Okay, so when you connect the electric field with the help of current collectors, this is called current collector. On one side, I'm keeping this current collector here. Okay, whatever the electrons generated conduct through this current collector, and to supply to the other side, one more current collector is there here. Okay, you can place like this. Okay, and through the electric wire, when you connect these two, so electric field is connecting. Okay, so now to avoid the short circuiting of current collectors, in between the plates, this is called gasket layer. Gasket layer is placed, on both sides of this membrane electrode assembly. Then once after placing the gasket layer, then keep the current collectors both sides. Now we can avoid short circuiting of this current collectors. Now with the help of electric wire through some external load, let us say bulb or motor, you connect these two through this external load. Okay, so electric field is generated because here electrons are generating, then electrons are reacting here, electric field. This is called complete fuel cell. Okay, so to assemble this, we need end plates to hold this current, the complete assembly. This is one side end plate, this is another side end plate. Okay, these end plates are firmly holded with the help of nut and bolt. Okay, now this is called complete fuel cell assembly. Okay, I'll repeat the operation. When you supply the hydrogen gas here, hydrogen, as soon as the hydrogen you supply, okay, protons and electrons are generating at the catalyst area. Electric field, electrons are available. Electrons are connected, with the help of current collectors. Okay, the electric field is electrons are connecting this side, anode side. So this is called anode side. This is called cathode side. Okay, so here you see interestingly the fuel cell operation. Just by supplying the hydrogen gas and supplying the oxygen here, okay, current is generating continuously. As long as you supply the fuel, it generates current. Okay, and the interesting point you have to observe in this fuel cell operation is it doesn't have moving parts, so less maintenance. Then long life, because wear and tear is not there, long life. Then emission from this cell is H2O. This is environmentally friendly, water vapor or water. And it is like, similar to the IC engine. As long as you supply the fuel, continuously generate the electric current. Okay, this is the upcoming technology. Okay, people are looking. So this is the operation of fuel cell practically used. Thank you.
Now, with that, I hope to some extent you understood the operation of fuel cell. Now, the more details about fuel cell. In the previous system, previous slide, in that system you have seen there are three components. There is a catalyst layer applied on both sides of the membrane. This is PEM, means proton exchange membrane. Then followed by gas diffusion layer. This also you might have seen the video. There is a carbon cloth. Then in that, one problem is there. Means when you supply hydrogen gas, there is no guarantee that that gas may be occupied throughout this space. If that space is not occupied by the gas, what happens? The chemical area available for that may not be utilized properly. That is why to overcome this problem, there is a flow field plate. FP means flow field plate. This flow field plate having internally the side groove, inner side, grooves are cut. Now, when you supply hydrogen gas, that gas flows it follows the groove, means it passes through this groove of this plate throughout this space and comes out at this side, so that gas may be available throughout this volume or throughout this space. And if that gas is distributed throughout that space, and here also chemical area is completely utilized, then fast reactions are taking place and better performance of the cell. So that is why in the operation of fuel cell, besides this gas diffusion layer and catalyst layer, flow field plates are used to distribute the gas throughout the chemical area available. Similarly, on the other side, oxygen supply is also with the help of the flow field plate, and this plate act as a current collector as well as flow field plate. Means it supports the distribution of fuel as well as whatever the electrons generated at this chemical area. You see here direction I have shown here. When you supply hydrogen gas, it is getting reacted here. Electrons available, the electron path is this one, like this. Then through this electric external wire, some load, electrons conducts from anode side to cathode side. So this is fuel cell. So now I hope you understood the operation of fuel cell. Any doubt on this topic? If you need any clarification, I can clarify. Otherwise, I'll go ahead. Okay. With that, now you see the application of fuel cell. So fuel cell can be used in cars in place of IC engine. Here, in the previous slide, I have shown single cell operation. So single cell hardly may generate 0.5 to 0.8 volt current. If you need some 10 kilowatts or 100 volts, so 0.5 100 means 1000 cells. 1000 cells when you keep in a series, you'll get 0.5 to 1500 volts current. Then that number of cells connected in series is called stack. So the Toyota company that prepared the fuel cell stack, and this may generate the power equivalent to the engine used in these vehicles. That power, whatever the engine develops the power, na, some, let us say 30 HP, 30 horsepower engine, 40 horsepower engine, like that. It is similar to that. The fuel cell stack is designed. Means here number of cells are connected in series. Then that system is called fuel cell stack. That stack can be placed by removing the engine from the vehicle, and this stack generates current almost equal to that engine, and the traction motors or electric motor may be used here before the gearbox. And then when you supply, the cylinders are stored in the chassis frame of the vehicle. You can see hydrogen cylinders. Then sometimes oxygen may be taken from ambient itself with the help of compressor. Now imagine by removing the engine and placing the fuel cell here, then fuel cell generates the current, and that current is supplied to that motor from there through gearbox and through differential without much modifications in the vehicle you can use. And also you observe, when imagine fuel cell is placed in the vehicle, means very silent in operation. Exhaust from the vehicle is water vapor or water, environmentally friendly, less maintenance because no moving parts here, particularly with regard to the engine portion, engine point of view. Fuel cell is used, no moving parts, long life, no wear and tear. Uh, so this slide I took from Professor Ajay K. Prasad, University of Delaware, US. So I have one collaborative project with him, and probably I mentioned I have one project. Spark project I have. Spark means scheme for promotion of academic and research collaboration. Spark, SPARC, scheme for promotion of academic and research collaborations, that is introduced by MHRD. Now it is called Ministry of Higher Education, Ministry of Education. Earlier it is called as a Ministry of Human Resource Development. That MHRD introduced this scheme in 2018, and they called proposals from Indian institutes as well as Indian institutes collaborating with foreign institutes. So I submitted two proposals, one with US country collaboration, another with Taiwan, National Taiwan University. This, the Professor Ajay K. Prasad, he has collaborated with my project. He has given consent to collaborate with our institute. He is from University of Delaware, and we got the fund worth of 43 lakhs. With the help of that, we can so many programs, and we can interact, and we can share the research ideas, particularly in the fuel cells. So I took he is working on the fuel cells. from his site I took this slide. Is Professor Ajay K. Prasad. He's of course he's Indian. He settled in US. He did his PhD in Stanford University, BTech in IIT Mumbai. So I'm fortunate to have collaboration with him. Here, one more point I want to mention. Besides the so many advantages in the fuel cell, you may get doubt. Sir, so many advantages, why it has not feasibly used? The only point is the storage and handling of hydrogen gas. That is the big problem. Scientists are taking it as a challenge. So if the technology is developed for storage, safe storage and safe handling of hydrogen gas, then readily we can use the fuel cell, and the IC engines may, you can call it as a, in future, if the technology developed means, so IC engines you can replace. Now coming to the analysis point, why it has that fuel cell has not become popular so far means one is storage and handling capacity, handling of hydrogen. Another thing with respect to the system, two key issues limiting the widespread commercialization of fuel cell. One is lower performance and high cost. So the performance can be increased once you understand the thermodynamics of the fuel cell. Now first I will discuss the theoretical electrical work, then thermodynamic analysis point I will discuss. Just a minute. Theoretical electrical work, how to determine how much electricity the fuel cell can generate. Because there is no combustion in the fuel cell, the relevance of hydrogen higher and lower heating value is used as a measure of energy input in a fuel cell. This is the maximum amount of energy that may be extracted from the hydrogen. However, while electricity is generated in fuel cell, in every chemical reaction, the amount of entropy is produced. Because that hydrogen cannot be useful work. The portion of reaction enthalpy that can be converted into electricity in a fuel cell corresponds to Gibbs free energy and is given by the following equation. Delta is equal to delta H minus T into delta S. So this is entropy generation. This is change of enthalpy that is converting into electrical energy. In other words, there are some irreversible losses in energy conversion due to creation of entropy. The delta H for the reaction is difference between heats of formation of products and reactants. That is, delta H is equal to enthalpy of formation of product minus enthalpy of formation of reactants, H2 and O2. Similarly, the change in entropy they can be determined with the help of this equation. The entropy formation of product minus entropy formation of reactants. So the value of HF and enthalpy of formation of means enthalpy of formation and entropy formation for the products and reactants, the ambient conditions, we can obtain from the properties table. So in general, electrical work is product of charge and potential. Electrical work is equal to charge to potential. So Q is the charge coulombs per mole. E is the potential, volts. The total charge transferred in a fuel cell reaction per mole of H2 consumed. For 1 mole of H2 consumed, how much charge is transferred is given as N into N Avogadro's number, means this is number of electrons per molecule of H2O, sorry, number of electrons per molecule of H2 hydrogen gas, and this is number of molecules present in a mole, and it is charge of 1 electron. So this equating, this is the charge transferred. So how many electrons are present in a molecule of hydrogen? How many molecules present in 1 mole? Because per mole of H2 we are calculating. Then charge of 1 electron. So the product of number of molecules per mole and the product of Avogadro's number and charge of 1 electron means Avogadro's number and charge of 1 electron, we can call it as a Faraday's constant. Product of Avogadro's number and charge of 1 electron is known as Faraday's constant, and its value is given as 96,485 coulombs per electron mole. So therefore, electrical work is related as N into F into E. So here, in the previous slide, you see W is equal to Q into E. Q is related as N Avogadro's number into charge of 1 electron, and these two we can call it as a Faraday's constant, NF, and you substitute here W is equal to NFE, you can get it, NFE. The maximum amount of electrical energy generated in a fuel cell corresponds to Gibbs free energy equation. It is equivalent to electrical energy is equal to the Avogadro's number. Therefore, the theoretical potential means how much is the potential of this, means voltage of the cell generates. So E is equal to, so in place of WE, substitute delta G by NF. So therefore, the relationship between voltage and temperature is derived by taking free energy, linearizing about the standard condition of 25 degrees Celsius, and assuming that enthalpy change does not change with temperature, means it is delta H is not affected by the temperature change. Therefore, E is equal to delta G by NF, or delta G is equal to delta H minus T into delta S by NF. So where E is reversible voltage and delta G is the standard free energy change for the reaction. So when you look into the, based on that previous equation, in case of hydrogen oxygen fuel cell under standard condition for the reaction H2 plus half O2 will give H2O, and from the properties table 25 degrees Celsius, delta H is equal to minus 286.02 kilojoule per mole, and delta G is equal to minus 237.3 kilojoule per mole. Therefore, the potential reversible cell voltage is equal to 1.299 volts. So, with the help of chemical equations available, how much one cell generates the voltage means 1.299 volts. This is at standard temperature and pressure, and this is the highest voltage obtained from hydrogen oxygen fuels. So theoretically, this much voltage is generated from the chemical reactions. But when you go for practical, means when you draw current from the cell, because other resistance terms may involve, means may contribute or may influence the voltage output, and that those losses, we can call it as a, that study of those losses can call it as a thermodynamic analysis. Another important performance parameter in the fuel cell is cell voltage is one performance parameter. Another one is cell efficiency. Though the efficiency of any energy conversion device is defined as ratio between useful energy output and energy input. In case of fuel cells, the useful energy output is electrical energy that is developed or produced, and energy input is enthalpy of hydrogen, because here the fuel you are supplying is hydrogen. So hydrogen higher heating value, you can consider it as a input to energy, and whatever the electrical output you are getting from the cell is output, cell output. Therefore, the maximum possible efficiency of the fuel cell is given as delta G by delta H. So 273.34 by 286.02. So you will get 83%. So maximum mechanical efficiency means maximum the cell efficiency can be attained in the fuel cell, that is 83%. Now, why you are going for thermodynamic analysis? I already mentioned thermodynamic analysis is going to study the losses influencing or incurred in the operation of fuel cell when you draw current from the cell. That is the point here I mentioned. In the application of fuel cells, it is expected that to generate electricity from the hydrogen, the performance of cell must be high. However, some problems such as decrease in performance stemming from thermodynamic reversibilities in the fuel cell, they arise during operation. So the analysis of thermodynamic analysis, other way you can call it as electrochemical model. Here, those points I'm going to discuss. Useful work is obtained from the fuel cell only when current is drawn. When you draw current, then it starts means it starts its operation in the form of chemical
In
reaction.
the morning.
Sir, 3 times 6,000, 6,000, 6,000.
Yeah, yeah.
Okay. Please do not share your ATM card, PIN number, and other information.
Okay.
The actual cell voltage, the reversible cell voltage decreased from its equilibrium thermodynamic potential because of irreversible losses. See, when you look into the chemical reaction of the fuel cell, H2 plus of O2, you can get electricity plus H2O plus heat. The actual cell voltage is given as reversible cell voltage minus losses. Here, what I mean to say here is, I'll go back to my previous diagram. Here, you see here, when you connect the external circuit from anode electrode to cathode electrode, then only the fuel cell operation starts. Otherwise, what happens, if you keep this wire open, what happens, hydrogen may enter here, that may split into ions and electrons. Then ions may conduct through this, then electrons may present here, and there is no means to transfer the electrons from this side to this side. So means up to this portion, the reactions may happen. After that, it stops. So to continue the operation of fuel cell, we must connect anode and cathode with the help of current conductor. So when you draw current from this cell, here theoretically the cell is generating 1.299 volts, but when you draw current with the help of external circuits, what happens, other resistances are means involving here, means there is a this whatever the electric wire you are using, it offers some resistance to the electron flow, and whatever the membrane you are using, it offers some resistance to the conduction of protons. This is one loss. And also at the chemical reaction, as soon as you supply gas, there is no guarantee that immediately it participates reaction. It may take some time to react. And also on this side, when you draw more current, higher current, what happens? Reactions are taking place at a fast rate, and the water generation here is more than water removal rate. Water generation rate is more at the cathode side than the discharging rate, means water may accumulate here. Once water accumulates means it occupies the chemical area and it obstructs the oxygen to reach that area and starts reacting. So these are the losses generally arising. So the loss which influence the reaction rate is called activation loss, and the loss which offers resistance to the current flow, it is called Ohm's law, and the loss which contributed by the accumulation of water, it is called concentration loss. So those losses I'm going to discuss now. So the topic which deals the study of voltage losses is called thermodynamic analysis. See, these are the losses. One is activation loss, ohmic loss, and concentration loss. Some of these losses you can call it as irreversible voltage. Irreversible voltage. So in the operation of fuel cell, these losses must be considered. Otherwise, if these, ideal case, if these are zero means whatever the reversible voltage is equal to cell voltage. But practically, we cannot avoid these losses. So that is why we have to consider, means we have to take into account these losses in the operation of fuel cell. Therefore, cell voltage is equal to reversible cell voltage minus losses. So now we'll discuss the mathematical model to see what is the effect of the temperature and pressure on the temperature and pressure of supplied gas on the performance of fuels. So we have set of equations. Please follow, all of you. This is very interesting, and you can start analyzing mathematically the cell performance, or you can give this topic to your UG students for their final year project. Then very interesting study we can get it here. So one by one I am explaining. I'll go back once again. See here, total number of parameters. Cell voltage is equal to reversible cell voltage minus activation loss, ohmic loss, and concentration loss. Now I'm going to give from the literature, we have set of equations available to determine the reversible cell voltage. Similarly, activation over potential means activation loss, ohmic loss, and concentration loss. Once you have these set of equations, and you can see in all the equations, the variables are involved, and you see if you keep one variable constant, one variable is changed by keeping other variables constant. Now observe the influence of that variable on the cell voltage. That is analysis part. This is called thermodynamic analysis. So reversible cell voltage is calculated from the energy balance between reactants and products, and it is given as 1.229 minus 8.5 10 to the power of minus 4 into capital T minus means temperature of cell minus 298.15 means the ambient condition plus 4.3085 10 to the power of minus 5 into ln of partial pressure of hydrogen gas and of ln of partial pressure of oxygen. So here the partial pressure of hydrogen and oxygen can be further related as hydrogen mass fraction into PA means pressure on anode side, means hydrogen pressure gas means hydrogen gas pressure. Anode side generally hydrogen is supplied. Similarly, partial pressure of oxygen is related as mass fraction of oxygen, and uh, oxygen gas is supplied on cathode side. The subscript C represents cathode, subscript A represents anode. So the oxygen gas pressure on cathode side, and these two mass fraction of hydrogen and oxygen can be further related as 1 minus the water molar fraction on anode side by the constants. These are the constant values. The water molar fraction on anode side can be uh, related as saturation pressure of uh, gas and divided by hydrogen gas pressure on anode side. Similarly, molar fraction of oxygen related as 1 minus XH2O subscript C means cathode side by constants, and the water molar fraction on cathode side P saturation by P. So the saturation pressure, water saturation pressure is function of cell temperature. So log of P saturation base 10, we have the equation in terms of temperature. So here, you please observe, if you want to write small program code, here I will give hint. All of you please follow. Simple, a code you can generate or code you can create with the help of these equations. In that code, first step you write log P saturation by base 10, this value, T you keep it as a variable. Now, next step is, so once you determine P sat using previous equation, now you write the relation XH2O at cathode is equal to P saturation means previous, with the help of, here in this equation, once you substitute T value, you'll get one value. That value can be substituted here, and then you give the cathode side pressure means oxygen gas pressure 1 bar you give. Then you can determine this value. Once you determine this value, now you write this equation in the code, 1 minus of this value divided by constants, you'll get mass fraction of oxygen. Similarly, using P saturation value, determine the water molar fraction on anode side and substitute here, you'll get water molar fraction of oxygen, hydrogen. Then once you determine, write the program in this way in a reverse direction, you will get partial pressure of hydrogen and partial pressure of oxygen. Those two values you substitute, you will get the reversible cell voltage. So just by here, what I mean to say here is keep T is a variable and pressure of oxygen gas and hydrogen gas, you give some values, inputs PA is equal to 1 bar, PC is equal to 1 bar. T you keep it in loop. T may be varied from ambient condition to 100 degrees. And for each input value, means for each value of T, and you give some increment 30 degrees, then 35 degrees, 40 degrees, like that. In the loop you keep. Then just by, once you write this program code, either in MATLAB or in C program or Python, whatever the programs you are familiar, generally students are, they may be they may be fast in writing the program code and running this program. You can give this work to your students, and you can study there as effect of temperature on reversible cell voltage just by giving these values. Now, once you identify that at particular temperature, E is maximum, means now that temperature you fix here, then observe variation of hydrogen gas pressure on the cell performance. Change this value, then determine. Similarly, you can arrive on value which will give maximum reversible cell voltage. Similarly, this value vary, or saturation pressure also you can vary by varying the temperature. So like this, you can mathematically analyze, means numerically numerical means that is simulation, but mathematical calculation means using these values we can do number of you can call it as a changing the variables, the number of times when you run the program, then you can see the behavior of cell with regard to the temperature, with regard to the pressure, like that. Okay, so far whatever the equations I explained, they are useful to determine the reversible cell voltage. Now, actual cell voltage is reversible cell voltage minus the losses. So how to quantify these losses? So we have set of equations available in the literature. Now first I will discuss the activation loss. Activation losses are caused by slowness of reactions taking place on the surface of electrodes. I already mentioned at the catalyst area, as soon as the hydrogen gas reaches, it starts splitting into protons and electrons. How fast that hydrogen gas is splitting into protons and electrons is studied by this activation process. And if it takes more time, means activation losses are more. If it takes less time, means activation losses are less. So to overcome that loss, portion of voltage generated is consumed in overcoming the chemical reaction that transfer the electrons to or from the electrode. And there is an equation given by I et al. That equation is called Teffel equation. The anode, V anode is equal to the gas constant by fuel cell temperature by alpha A, means stoichiometric ratio, means how much percentage of hydrogen in a mixture of humidified. Generally, hydrogen gas is supplied in humidified form. That is called stoichiometry. Number of electrons, Faraday's constant. I means how much current you are drawing. Then this is exchange current density. This you can get from the literature. Similarly, at the cathode side also reactions are taking place. So it is gas constant by temperature of fuel cell by stoichiometric ratio into number of electrons, Faraday's constant. So using this sum of these values means this term plus this term will quantify activation loss. So that is depending on how much current you are drawing from the cell. Similarly, the other loss is ohmic loss. Ohmic loss means as the electrons are conducting through the wire material offers some resistance to the flow of electrons. That is studied by Ohm's law. So ohmic overpotential arises from resistance of proton exchange membrane to transfer the protons, means membrane offers some resistance, and also resistance of electrode and current collectors to transfer the electrons. It is simple. V is equal to IR. Ohmic overpotential is equal to V is equal to IR. But here, the resistance of wire can be readily available because when you use copper wire, we have that material resistance. We can get it from the properties of the copper. Then membrane resistance, how to determine is the relation is given here. It is thickness of the membrane by membrane conductivity. So R ohmic is equal to thickness of membrane by membrane conductivity. Membrane conductivity is related using this relation where lambda mean, this is the water content, membrane water content is related is the help of this equation. So here, if the value is between 0 and 1, we can use this value. If 1 is less than means if the value is means this value is in between the 1 and 3, you can use this relation for membrane water content. Then other loss in the fuel cell is concentration loss, or other way you can call it as a concentration over potential. This is mass transfer limitation. I already mentioned, if cell operates at very high current density, this term needs to be included because water may be getting accumulated at the cathode side, and that may obstruct the catalyst area, due to which oxygen may not reach that area and may not react. So for that, the empirical relation given as I into beta I by I maximum whole to the power of beta 2, where beta 1, beta 2, and I maximum are the constants that depend on temperature and reactant partial pressures and can be determined empirically. So once you have the beta 1 can be related further using these relations. So if this value is less than 2 atmosphere, you can use this relation for beta 1. Else, you can use this equation. So once you have, the ohmic overpotential relation, then ohmic concentration and activation, these values, we have the mathematical relation for activation loss, ohmic loss, and concentration. You substitute this in this equation, then you will get cell voltage. So cell voltage means that is depending on current you are drawing. If you are at low current density, cell voltage may be maximum. When you draw more current, cell voltage may decrease, because as the current you draw, faster reactions takes place. Due to that, the losses may also proportionately may increase. That is why as current is drawn more, cell voltage decreases. So once you have cell voltage and current, a product of cell voltage and current will give power. So that is the power output of the cell is equal to V cell into I. Therefore, V cell is E minus V activation, V ohmic, V concentration into I. And this is the power output. Power input means what you are giving to the cell, the power input to the cell is hydrogen gas you are supplying. Hydrogen gas higher heating value, number of moles of hydrogen reacted minus, this is minus, number of moles of hydrogen reacted out, means some amount of hydrogen may come out without participating in the reaction. So here it is, please observe the change. So the number of moles of hydrogen reacted, this is unreacted gas, then higher heating value, hydrogen higher heating value. This is the power input. Therefore, fuel cell efficiency is equal to power output by power input. You'll get it. See, any doubt on this? Yes? All of you, are you following what I'm explaining? Seems to be new area. Seems to be new area, but there is a large scope for the projects as well as for the publications. And this system is also come under renewable energy because hydrogen is abundantly available. Means even seawater also you can use for generating the hydrogen gas. So wherever the water is available means hydrogen is obviously available. Those who have doubt, how can you get the hydrogen here, means as long as water is available and the earth, we can get the hydrogen gas. And this gas is non-polluting because no carbon present. When the hydrogen gas participate reaction with oxygen, so we can get clean energy without any pollution. So here, whatever the mathematical expressions I explained here, I written program, and these are the parameters I kept. cell temperature is varied 323 Kelvin to 353, and pressure is varied 3 atmosphere pressure to 5 atmosphere, and membrane thickness I varied the 0.016 centimeter to means these are the standard membranes available in the market. So these are the graphs I got by writing the program on this. So from this graph, you please observe these lines represents efficiency. These lines represents irreversible voltage means losses here. Loss. Please observe. Don't think that this is voltage. It is irreversible voltage means irreversible loss. Loss. So as temperature is increased from 323 to 353, you see here uh, this is 323, this is 353. So loss is getting decreased. When loss is getting decreased, efficiency may increase. You see this blue color line you see here, it has come top here. Here it is at bottom, means blue color line represents 353 Kelvin. Loss is getting decreased as temperature is increased. Proportionately, efficiency of the cell is increased. So this is one observation you can make with the help of those equations available, mathematical equations. Similarly, effect of pressure on cell performance. This black line is low pressure, medium, high pressure. As pressure is increased, loss is decreased here. Sorry, loss decreased, yes, and efficiency is increased. Then in two diagrams, you may get doubt. Why you have stopped at 353? Why can't you go for 383 or 400 or 500 or 1000 like that? So in the cell, the membrane is used now. If you go for very high temperatures, beyond 100 or 200 degrees Celsius, what happens, because of heat, the membrane can get dry. It may not be in humid form. It may get dried. So dry membrane may not conduct the protons properly. So that problem is there. So all of you please observe that at high pressures, also high temperatures membrane is dry. Then high pressures also, the problem is why can't you go for high pressures means here the energy required to store the gas is more, and sometimes whatever the energy we are obtaining from the cell may not be equal to that also. That is why to balance that, to compensate or to balance that, no energy required to compress the gas, and whatever the gas you are using to generate energy, electrical energy, there must be a gain. So that is why high pressure means at high pressures compression of hydrogen is also not economical and not safe. That is why a stop is going for beyond 5 atmosphere. Similarly, the membrane thickness effect on performance of cell, you see, the thickness of membrane is increased. Here, the blue line is representing thin, then medium and thick. So thickness is increased means loss also increases. So thin membrane may offer less resistance. That is why thin membrane is giving maximum efficiency. So this is thermodynamic analysis of fuel cell. Now, I already mentioned in our department, we developed some research facility. There, mainly we are working on flow field plate designs. Flow field plate designs means in the fuel cell, I already mentioned, this is the exploded view of fuel cell. This is the membrane and catalyst material. To supply gas, what happens, that gas may accumulate at one place. It may not distribute throughout the space. Instead, if you use flow field, that flow field may give path to the gas flow, and gas may pass through this path. Then, so it occupies more complete space available for the catalyst area. So these flow field plate design, this design influencing much on the performance of the fuel cell. So we have designed different types of flow fields. This is one shape of the flow field. This shape is called serpentine shape. Means gas may enter here, flows through this groove like this. By the time it comes, it occupies complete space. Then next to this, catalyst material is there that reacts the gas, splitting into electrons and protons. Electrons may conduct through this plate itself. This plate is bipolar plate. So made up of graphite. It is acting as a flow field plate cum current collector also. It conducts better way electrons, and also it is non-reactive. Means even hydrogen gas, oxygen gas, humidified gas, so non-corrosive this one. That is why graphite material is used. But one disadvantage means it is very brittle material. So another shape of the flow field is lung channel. Our human lungs are there, na? This side. So from here, gas may enter, may distribute both sides, and it may come out here. So this is, people observed that gas distribution is perfect in our lungs, oxygen distribution. That is why that lung channel design also we attempted for supply of oxygen and hydrogen. And this is leaf channel. Because of photosynthesis in the leaf, means the plants, there also better distribution of the photosynthesis. So this is biochannel, you can call it as. And this is another leaf channel. So these are the different flow fields we have designed. First, initially, our scholars, they did simulation work initially, and whatever the profile or whatever the shape or configuration which gives better performance that can be obtained in the simulation using study, that is using Fluent, that is saving our money as well as time, so that once we get the best configuration from the simulation study, the best
స్క్రీన్ రికార్డింగ్
configuration.
పెట్టాలి సార్, స్క్రీన్ రికార్డింగ్ పెట్టేసుకున్నా ఇది నాకు, ఎందుకంటే ఇది రికార్డ్ అవుతుందని యాడ్ చేయడం తెలియదు కదా. దీంట్లో అనేది మీకు ఒక పార్ట్ చూపిస్తుంది, అది ఇటు చూపించండి సార్.
Best configuration, whatever the simulation results we are obtaining.
ఇప్పుడు చూపెట్టినా సార్, ఫస్ట్
Better
సార్ రికార్డింగ్ రికార్డింగ్
that design we have given order for the manufacturer to manufacture the condition.
రికార్డ్ ఆప్షన్ చూపిస్తుంది.
Participants, please mute your mic. See, in the simulation study, we can arrive best design. Based on that, with the help of that that best design configuration, we can give it to the manufacturer. He can manufacture the plates like this. So these are not photographs. These are plates, original plates we are using in our lab. And this is the test facility in our department. Here, this one, I think actually this is fuel cell, and as the actual, this is the just schematic diagram. This is actual fuel cell, and this fuel cell is connected to the test station here. All of you are able to see, I think. This is test station. Test station, why it is required, directly the fuel cell is not connected to the cylinders here. Because for the, in the previous slides you might have seen, at different pressures, different temperatures, gas is supplied, different mass flow rates, and different humidified gases. So like that, those parameters can be varied with the help of this test station. In this test station, that facility is there. Here the three pipelines, hydrogen gas, oxygen, and nitrogen, these are taken from this gas bank system. So this gas bank system is placed in some isolated area for the safety purpose, and these pipelines are taken to this laboratory here, and these gas pipelines are connected to this test station. In the test station, the facilities available are mass flow controllers are there, then line heaters are there, then pressure gauge means pressure regulators are there, and this test station is interface with the computer, so no need to manually operate here the by closing and opening the valves here, because it is computer interfaced. This is programmable test station. We have purchased this test station from Vanatech company, Korea, imported. It is costing about 36 lakhs in 2014. I purchased this. We have to equip two funds, and here the computer, the console here, everything you will get it details about the mass flow controller here, valves here. So just by operating this console in the system, once you open this valve, here valve getting opened. If you close that, it will be closed. Then if you set some temperature of supplied gas, then line heaters are come into activation. So mass flow controller, mass flow rate can be controlled, then temperature can be controlled, and pressure. So once you set whatever the required conditions, now when you run this one, automatically the test station runs and supplies the gas to this cell. So here this cell is connected, and the generated current here you can see the computer monitor itself. And also here number of tests also we can conduct. Means once you apply load, zero load on the cell, then 0.1 amperes, 0.2 amperes, 0.3, like that, number of time steps, as well as increment of current, as well as at each current how much time it has to run, like that. Then on Excel sheet you can generate complete result, and even graphs also you can attain. So testing time is very fast here. So once you fix the cell with the required condition and fix it on the test station, we can get the result directly on the system, and it will save a lot of time for my scholars to do their research. So this is the test facility available in our department, means in general our institute. Myself is looking after this test station, and I think myself only initiated the purchasing everything. With the help of TechU funds, we have to say thanks to the World Bank for providing the funds under TechU 2. Then based on this, I written the proposal for the SCRB to work on another type of fuel cell, that is direct methanol fuel cell. So they readily accepted. In 2017, I got the project of worth 20 lakhs. And with that, we have developed direct methanol fuel cell also. I'll show that. Direct methanol fuel cell. See, in the previous, that is previous cell is proton exchange membrane fuel cell, where we have to use hydrogen as the supplied gas and oxygen for the reactant. Then I already mentioned hydrogen, we have one issue, that is safety issue. To overcome that, then direct methanol fuel cell we attempted. So here direct methanol means in the liquid form, and that to diluted liquid. The same membrane can be used, means whatever the catalyst material same. Instead of supplying hydrogen gas, we can supply methanol, direct methanol in liquid form. So direct methanol fuel cell better suited for power hungry portable devices than PEM, which is supplied by hydrogen and oxygen. This is primarily due to ease of handling, means liquid fuel, easy to handle, and high theoretical energy density, means space occupied by this methanol, liquid methanol, is less than gaseous fuel. And of course, working principle is same, but only problem is the methanol CH3OH, we can get the carbon dioxide here, but rate of generation of carbon dioxide is very less. When you supply CH3OH on this side with diluted with water, so what happens? You know, these are the reactions taking place on the anode side: CO2 plus 6 electrons and 6 H plus ions. And other side, you supply oxygen gas, then 3/2 O2 plus 6 electrons and 6 ions, H plus ions, you can get 3H2O. So at each mole of the CH3OH, means for each reaction, 6 electrons are participated this. So here, two types of direct methanol fuel cells are there. Means one is active direct methanol fuel cell and passive direct methanol fuel cell. In active direct methanol fuel cell, let us say this is the fuel cell, just schematic representation only. You supply methanol, liquid methanol with the help of pump that may participate in the reaction. Unreacted methanol may come out. Then other side, oxygen cylinder is connected and supply the oxygen to this. So here this is called active methanol fuel cell. But when you go for passive system, no need to maintain pump this side, just place the fuel reservoir here itself. Continuously it supplies, it is in contact with the membrane catalyst. Okay. Then other side, keep open this end, means oxygen is available from the, means it takes oxygen from the ambient. So this system is very simple and easy to handle. So on this system only I did my project, means that SERB project proposal I submitted on the passive direct methanol fuel cell. When you see the components here, it is simple. This is membrane electrode assembly, and there is a current collector with holes, means provision to allow the fuel from this side to this side. Here, this is the fuel storage, fuel tank. So some 30 ml to 40 ml of methanol can be stored, and that is passing through these holes and reaching the catalyst area. Reaction starts, electrons are generated, they may go to this, and other side, just keep open cathode side, oxygen enters through these holes and reaches here, complete the reaction, then generates the current. So whatever the video I have shown at my starting of this presentation with regard to the direct methanol fuel cell, which we have designed with the help of funds available from the SERB, DST SERB. So here, those who have interest, you can start this experiment. So to design this cell, just we need these components. No need to maintain hydrogen cylinder or oxygen cylinder here. And also, our aim is, means our target is, still we are working on this. Target is design this system as compact as possible and make this like a power bank is there now in our cell phones, to that shape, just by filling the methanol inside this. That is not that much harm, because methanol is diluted 90%, means 90 ml in a 100 ml mixture, 90 ml is the water and 10 ml is methanol. That is not that much danger. And once you fill 100 ml of methanol here and you continuously draw current from this cell, means once you fill this methanol here and switch on the current, means supply current or draw current from this cell, then it starts reacting because it takes the oxygen from the ambient. It is almost like power bank, it works. I think I already mentioned, we are targeting to design the cell which supports charging of laptops and charging of cell phones at present. Even we can advance it, the system. Even the battery and the cell phone can be replaced with the help of this direct methanol fuel cell. So this is one design I collected from journal paper, and this is the actually direct methanol fuel cell connected to run the fan. And if you connect, another important point here, by using boost converters, DC-DC boost converters, that may enhance the cell voltage 3 to 4 times. Let us say cell generates 2 volts, means if you connect boost converter, DC-DC boost converter, and boost converters are available with USB ports. If you connect this boost converter with the cell, the boost converter enhances the cell voltage to 3 to 4 times, and with the help of USB converter you connect to the cell phone getting charged. And this is just supplementary. Already in the cell phone battery is there, but our target is even to remove that battery and keep this direct methanol fuel cell inside the cell phone itself, so that no need to recharge every time. Just by refilling that methanol solution, and it can continuously work. Even if you go for remote places, no need to depend on conventional current. Here itself current generates, and its duration is long. Consumption rate is very less, and also cost is also very, very less. And life, that charging, decharging problem may not be there. Life is more. So with this, I'm concluding the presentation. In this thermodynamic analysis, to decrease the losses, PEM fuel cells should be operated at higher cell temperature for a given operating pressure and membrane thickness. When the proton exchange membrane fuel cell is operated at constant temperature condition, and also by keeping the temperature and membrane thickness constant, higher operating pressures can be selected to decrease the thermodynamic reversibilities. And with regard to the membrane thickness, lower membrane thickness must be used. And in case of direct methanol fuel cell, 2 molarity means in 100 ml, 4 ml is the methanol and 96 ml is the water. That is 2 molarity. There is an equation, rough value I am telling here. 2 molarity methanol concentration gives better performance at lower current densities compared to 4 molarity concentration. Here, what I mean to say here is, if you know, if the requirement means demand is at low current density, then don't go for high concentration methanol. Low concentration methanol is enough. Similarly, methanol concentration and anode catalyst layer decrease linearly with increase in current density. This is obvious as methanol will consume at a greater rate to generate high current. So thank you.
Sir, can you show the 54th slide?
Okay. Yes. Is this one you are asking?
Sir, yes, sir. Yes, sir.
So here, you please ask your doubt.
How this works, sir?
See here, this is the membrane. I have shown in my video. There is a membrane.
Yeah, yes, yes.
Both sides catalyst material is coated. This is catalyst material. Now this is the flow field plate. If you supply CH3OH here, so that methanol solution may reach through this diffusion layer to this catalyst layer, where reactions are taking place. these, what are the reactions exactly? Here it has shown anode side. CH3OH plus H2O means water and methanol solution splitting into 6H plus ions, and CO2. CO2 may not be conducting through this because this membrane offers resistance. No? CO2 gases may come out back, CO2 gases. So H plus ions may conduct through this membrane to cathode side. And cathode side oxygen is supplied. Now you see oxygen. Oxygen is reacting with 6H plus ions. And electrons, here electrons are available no? With their external circuit. The current means electric wire is connected through load here. So electrons are coming from the external circuit, and oxygen and 6H plus ions react and form as a water here. So here he mentioned air or oxygen. Oxygen enters, reacts, and then water is formed. So this is the cathode side reaction, and this one is anode side reaction. CH3OH is the chemical formula for methanol plus H2O means water and methanol. See here, pure methanol cannot be supplied. Always it must be diluted with water, and this is the reaction taking place on the anode side. Similarly, cathode side, O2 reacting with H plus ions and electrons, then H2O form. Overall reaction you see, CH3 plus OH plus half O2, 1.5 O2, 2 by 3, 3 by 2, is equal to 2 H2O plus CO2. This is the reaction.
Thank you, sir.
Will anybody wants to interact with the Srinivasulu sir?
I think
Hello,
some seems to be new area.
Hello, sir.
Yes, please.
Excellent presentation, sir.
Thank you, sir.
Explained interestingly and very systematic way. Okay. Thank you very much, sir. One question, sir. Can we? What are the different types of membrane materials, sir, we can have for the fuel cells?
Yes, sir. Actually, so far membrane materials, Nafion membrane is used, sir, popularly. Nafion.
Okay.
Nafion is used. That is DuPont company manufacturer. That is somewhat because of that. One of the reasons why practically fuel cells are not mass production used. Only one company manufacturing Nafion material. That is better performance, but high cost. But even in IISc Bangalore and other IITs, even in our institute also, people are working some low cost membranes, sir. Like these nano material means nano composites, using nano composites. I didn't remember exactly the scientific names. Other materials are available, but still they are in research stage, sir.
Okay.
One popularly used is Nafion material.
Nafion, okay.
We are also using Nafion material only, sir, in our research.
Okay. But the amount of power produced is a little bit low, no, sir, from this fuel cell.
Single cell is low, sir, but when you make it, stack, connect all number of cells into series. Even in battery also a similar way, sir. Battery also, it is a combination of cells, no, stacked in a group. Battery also. Similar way, here fuel cell also. Single cell, 1 centimeter square area, develop 0.5 volts. But if we go for more area as well as number of cells, then we can obtain the required power, sir.
Sir, can we try this fuel cell for a BTech project, sir?
Definitely, sir.
Sir,
So whatever the equations available here, you can write simple code Then by varying, so many parameters are there. Keep one parameter variable, other parameters constant, then run the program.
In MATLAB, we can write the code, no, sir?
Yes, sir. In simple equation. MATLAB, we have done, so many trials, and even my BTech projects, every time they are being, and other, once you enter into this area, then you'll get more information, and you can go through number of papers, then more ideas can be attained, means more ideas you can gain from that. So once you start, then you can get the information automatically, sir.
Okay, sir. Thank you very much, sir.
Thank you, sir.
Still anybody? Still anybody wants to interact? I think no participants are interacting, sir.
No problem, sir.
Okay, sir. If anybody wants to discuss, so you can send the email to sir. Sir will give the explanation. So there is no problem. So thank you, sir, for accepting our invitation and for a excellent session on this day. So I sent one email to you, sir. So you please
Sir.
fill that Google form. So thank you, sir, once again.
Thank you, sir. I thank thank you very much, sir. Particularly, I'm thanking you for giving me the opportunity to share my research contributions to the participants, and I also thank the participants for their patient hearing, and I once again thank your management, sir, and organizing committee. Sir, thank you.
Once again, we will meet you, sir, for the second phase. Sorry, for first phase. This is the second phase. So contact you for the phase 1, but that is not organized as per the plan due to COVID. So once again, contact you, sir.
Yes, sir. Thank you, sir. Shall I leave the meeting, sir?
Yeah, you can leave, sir.
Okay. Thank you.
So, dear participants, this is the today's session, and tomorrow we'll have the session by Rangaraj, Deputy Director, National Institute of Indian Energy. He is going to give a topic on renewable energy data analytics and wind power forecasting. So all of you join by 10:30 on 23rd 12 2020. So thank you for joining and enjoying the session.
Thank you, sir. Thank you so much.
Thank you. If anybody wants to tell something, because this is I think 8 days are over.
Sir, night sessions going.
9 days. Only 3 days are left.
Please ask the presenters to provide their PPTs if possible.
So thank you so much.
Because everything is recorded, and so you will get YouTube links. So don't worry.
Okay, sir.
And also we can give this videos also, video links.
You please provide a video links to our mail, sir.
Yeah, sure. So we have the mails. We'll send the video links. So and also you can get in the YouTube also.
Okay, sir.
Well, that's it.
Thank you.